This is going to be a short video on the Clubfoot Escapement. About a year ago, one of our users had requested that I look into adding a clubfoot. There's a couple reasons for doing so. Unfortunately, when I looked at it, I came to the decision that Garrotic was getting a little archaic in its code for me to keep adding things. So I never did get around to adding it, but the same user asked again this year if I'd consider it, and I really think it's important that we have one, so I did add this module to Vex. To operate this module is pretty easy. I'm just going to cancel out of this. There's a button down here on the bottom on the menu called Clubfoot Escapement, and if you press it, you will come up with some default readings depending on whether you're in metric or English. And if you hit the regen button, you'll come up with an escapement. Now there's a simulator button here if you wish to simulate it to see exactly how it works. And the only size constraint that you have for this escapement is this shaft to shaft distance. In the end, your escapement will be this distance from shaft to shaft. This allows you to create a clubfoot as a drop-in replacement for anything that you might create in Garrotic. Now this module does not give you spokes or anything fancy with your escapements, but the only thing important about a clubfoot are the teeth at the top of the ratchet and the two teeth that are on the pallet. So you're free to change the drawing as much as you like, as long as you keep those the same. Now, the clubfoot, there's not much information on how to draw them, so all the information for this one was taken from Project Gutenberg, and I derived the parametric formulas from there. So you are free to select any size that you wish. Now, as you go up, if you go towards a 30 tooth, which some people would want for a clock, you'll see that this is far too short a span for it. It would be hard to fit it. So there is a tooth span setting, which I'll set to 5.5. You will always have to set it to the half tooth. So a number like 5.5 and hit regen, and you'll come up with a much more reasonable palette. The drop and lock are probably the average drop and lock that a person would want to use. Oh, in fact, the only thing I allow on this one at the moment is drop angle, and that's the angle if we stop the simulation and hit regen. That is the angle at which we'll strike, where the ratchet tooth will strike the pallet on a recoil as it goes. Now, normally you'd leave that at 1.5 degrees. That tends to be fine. If you really want to get that close, you're free to lower it. If we take this down to 0.75, for example, and do a regen, you can see that now our teeth and the teeth shape have changed, and we have a much shorter drop rate. Now the line of action on this is set to 10 degrees and a 15 tooth escapement, and because the size of the teeth are somewhat proportional to the action that you get, I've taken the liberty of changing the action dependent on the size of the number of teeth. So if you go up to 30 teeth, you're going to have about a 5-degree action. If you're at a 15 tooth, you're going to have about a 10-degree action. Anything less than 12 is considered good as per spec. Now it is possible to screw up the simulation if you go to extreme numbers. If, for example, I told it to do an 8.5 tooth span on a gear such as this one, you can see things begin to screw up somewhat, and it's probably not a good idea to use such an escapement. So use the fact that you have fooled my simulation as reason not to use an escapement, although this one could probably be used if you were to increase the root depth and fix up this end curve. I'll take that back to a 5.5 tooth escapement, and our 5.5 tooth looks a lot better on that. Typical for a clubfoot is 15 teeth. While I've been playing with this, I've come up with the idea of a clock that I'd like to try, so I'll probably make one of these and post a video on it hopefully fairly shortly. Anyway, if you like what you see as the escapement, just press the OK button and you will be given a CAD program of it. You're free to modify this, as I said, as long as you respect the teeth themselves. Anything else can be changed. You can add spokes and so on and so forth. One other thing worth noting, if you want to use this on a 3D printer and you just want a quick print, if you select both of them, select Edit and Group, you can now use the Group button, Group Extrude, and set it to a particular thickness, and when you hit Go, you will now be given a solid. Unfortunately, the holes don't seem to have made it into this solid, and I'll have to check out why, but that's future work. So that's it. That's how a Clubfoot escapement works, and how you can get one as a drop-in replacement for Garrotic's older escapement types. Have fun.